Hello, I have a test on chromatography. So we're going to do chromatography. Oh my god. Oh well. So basically, first question says an analytical chemist is testing a mixture containing three compounds, hexane, hexanol, and hexanal. The mixture is injected into a high-performance liquid chromatography instrument utilizing a reverse phase setup. And for the first part, we have to predict the exact elution order from shortest to longest retention time. So basically, or because it's reverse phase setup, normally the stationary is polar, and the mobile is nonpolar. But now the stationary is nonpolar and the mobile is polar. So that means the shortest retention time require the sample, okay, the section of the sample, no, the element, okay, yeah, or whatever. Um, the thing, okay, not the thing. The sample must be for it to be fat to be for it to have a smaller retention time. It must be polar, and we have um we have we have hexane, hexanol, and hexanal. So basically, we have hexane. So most polar one, because hexane is like normally it would not. It would be there's only dispersion forces because it's like symmetrical, and hexanol have a OH at the top at the end, so that have hydrogen bond, double double and dispersion, and ethanol is at the end is a carbon double bond O and a H, which means it doesn't have hydrogen bonds, so only dispersion dipole, which means uh, hexanol, hexanal, and hexane is the order. Um, this is because this is both a dipole hydrogen bond and dispersion, so it must be the most polar, and the most polar have the smallest retention time. And for part two of this, it says justify your order by identifying the intermolecular force. Basically, what I was explaining. So hexanol have all high have hydrogen bonding dipole dipole and dispersion forces. So that means it making it very polar, leading to smallest retention time in polar mobile phase. That's basically how you would explain each one. But I'm lazy, so I'm just gonna say, well, um, while hexanol don't have hydrogen bonding, so less polar, and hexane only have dispersion, so least polar. And then you would lead that to why it have more retention time. which is literally just because it want to stick to the stationary phase more, because it's more it's less polar. Because like dissolve like, it will be attracted to the stationary phase more, so it will decrease, so it will increase retention time. And for the second question, um, part second question, it literally says, okay, the World Anti-Doping Agency is investigating a blood sample from an athlete for substance a small, highly volatile stimulant, and substance B, a massive protein hormone that breaks down at high temperatures. For part A, it says to identify which technique must be used for each and justify why. Justify why. So, uh, gas. Oh my god, gas chromatography should be used for substance A, as it is highly volatile and high performance liquid chromatography can be used for a substance B, as it breaks down in high temperatures, so gas chromatography can't be used. I also want to include that TLC must, a thin layer chromatography must not be used, as it is not quantitative and and have low accuracy, I think. Reliability. Wait, it have, technically it have hmm, it's bad. But how can I explain it? It is it have bad precision and low precision. Oh well, that's good enough for explanation. For part B, it asks a laboratory uses normal phase HPLC to isolate substance B. Describe the relative polarities of the phases and explain how IMFs that dictate the speed of polar and nonpolar impurities. Okay. So basically, normal phase HPLC um, PLCs uses a polar mobile phase and non-polar non-polar wait, I did the wrong way around. Stationary mobile phase. Oh, okay. this means that polar analysts analytes, not analysts, analytes will that means this will want to stay in a stationary phase, will have longer retention time, while non-polar analytes will have shorter time. Part C says discuss the ethical and social consequences of if the equipment is not calibrated correctly. So basically, because of the serious use of chromatography in sport in sport and drug use substance use in sports, the results of the chromatography are highly important to the athletes' careers, making results of the tests highly important and the tests are not always perfectly correct and can ruin whole kind of repeating myself whole careers if tested wrong. I mean, and they focus on the ethical and whatever. What is it? Ethical and social consequences. So I guess it's fine. You can expand on that, but that's that. Oh well. Bye bye.